Okay, thank you for pressing play, and welcome to video number 18. This one is on graphing linear inequalities in two variables. So this video is technically optional. So if you're watching this, this is optional, but it's good to have notes on this. Again, you can use them for your test or quiz, and it's just nice to have to help you improve anyway. If you were absent any time last week, sophomores, FFA, talk people, this is definitely one you want to check out because you missed me go over the material in class. So anyways, the goal for today. So you want to obviously graph linear equations, this time in two variables. So with x and y, not just x, as it was in chapter 1. So here's our three-step process. You'll want to have notes on this. First off, solve for y. Second off, once you solve for y, you gotta ask yourself, is it going to be a solid or a dashed line? And if you're not sure what I mean by that, you'll see that in the next example. And then thirdly, do you shade above or below? Same thing. If you don't know what I mean by that, you'll see it in the next example. And also at the end, we're going to do the same thing, but a little step up with absolute value inequalities with two variables. This will be one of your homework problems I assigned done for you. So if you want to have some help there, you might want to keep watching. Okay, so the first example looks like this. Negative 3y is less than 5y minus 12. That should have been x. There we go. Negative 3y is less than 5x minus 12. So what I want to do is I want to solve for y. So my only step here is to divide by negative 3. But again, I got to divide by negative 3 to everything. Recall chapter 1, we isolated variables with formulas. This is y again, because we want to get our y's by itself to be able to graph. So I have y there, I have negative 5/3 x here, and negative 12 divided by negative 3, I have plus 4 here. But don't forget, because I divided by a negative, that sign switches and now becomes more than. So my final answer is y is more than negative 5/3 x plus 4. So now I have to graph that. So what I'm going to do is I'm going to draw my axes. Hold on a second. And there it is. So, of course, for now, pretend this was equals instead of more than. I know my y-intercept is at 4. So I'm going to start there, 1, 2, 3, 4. And there's my first point. And then my slope is negative 5/3. So again, that means, because it's a negative slope, I go down 5. And then right by 3. So from here, 1, 2, 3, 4, 5, 1, 2, 3. There's 1 point. And then I do it again. So 1, 2, 3, 4, 5, 1, 2, 3. Yep, right there. So 1, 2, 3, 4, 5, 1, 2, 3. Sorry, I lost track of where I was. Sorry about that. So there is 3 points. That's all I need for this line. So I'm going to graph the line. But this time, y is more than. Y is not equal to. Therefore, it's going to be a dashed line. If you had Algebra 1, this might be somewhat familiar to you. Hopefully it comes back to you. So it actually looks something like this. I did it by hand. You should take a ruler and do it the right way. Also, it's more than, right? Y is more than. That means I shade above. So then everything above this line gets shaded in. So any point in this shaded region, but not on the line, because the line is not part of the inequality, because it's not equal to. All this stuff is part of the solution set. So you can shade nicer if you want to. You can just do what I did and just put some lines there. Just make it obvious that you chose the region above. And again, how do I know this is above? Well, from my line, if I go straight up in the air, I'm here, right? I'm in this region. If this was less than, I'd go straight down, and I'd be over here on the left side. So that's how this one works. So let's go to the next example. So 17 is greater than or equal to negative 2x plus 4y. Again, I want to solve for y all by itself. So first thing I'm going to do to both sides, I'm going to add 2x. So then what I have is 17 plus 2x is greater than or equal to 4y. Well, I want y by itself, not 4y. So now I've got to divide everything by 4. And so I do that. And so what I have now is 17/4. So I'm going to make that a decimal for this problem. So 4.25. I'm going to keep the slope as a fraction, so 1/2, right? 2 divided by 4. That way I know how to move my equation when I graph it, or inequality, sorry, not equation. More than or equal to y. What I'm going to do here is just reverse it. So instead of having this, I'm just going to flip everything over. So y is less than or equal to, again, y was the left side, right, because it opened up to everything else. So y is less than 1/2 x plus 4.25. So this right here is my final answer. Well, at least the inequality, right? I've solved for y. Now I've got to graph it. So now I make my axes. Here they are, and again, assume every single grid spot is just 1. So I'm going to start with my y-intercept at 4.25. So it's up 1, 2, 3, 4.25, so it's something like there-ish. And my slope is 1/2. So that means I'm going up 1 and right 2. I'm just going to abbreviate that for now. So up 1, right 2, now I'm like here, right about there. Do it again, up 1, right 2, I'm about right there. I can also go, that's an or down 1, left 2. Right, you have to reverse both of them if you're going to go backwards. So down 1, left 2, I'm like there. Down 1, left 2, I'm like here. So I've got some points now that I can use. This time though, notice that it's less than or equal to. Because it's also equal to, this is going to be a solid line. So when I connect these points I made, it's going to be just a solid line straight through. Again, I'm doing this by hand on the iPad, so it looks somewhat sloppy. You can use a ruler and make it nice and neat. Also, y is less than. Because y is less than, I'm going to shade below, right, underneath. Because again, y is up and down, so I want everything down here. So all of this stuff here gets shaded. And you can color it nicely if you want. You can just do something like this, some kind of checkered pattern. Just something so that we all know which region you meant to shade in. So this, everything below this line, right, everything over here, even the line this time, because it's also equal to, is part of the solution set. If you wanted to, you could just plug in any point you want and it'd be true. So for example, I could plug in, let's say, the point right here. That point is 1, 0, right? X is 1, y is 0. If I plug that in right here, here's what happens. Y is 0. So 0 is less than or equal to 1/2 times 1 plus 4.25, right? That's my inequality. I just rewrote it with 0 and 1 plugged in for x and y respectively. So when I plug this in, I'm checking it, and this is obviously true because this is going to be 1/2 plus 4.25, that's like 4.75, and that's obviously more than or equal to 0. So it checks out, right? So I plug in a point, any point I want in this region, and it's going to make the inequality true. If I plugged in any point over here above the line, it should be false. And in this case, anything on the line should also be true. In the last example, anything on the line, if you picked any points here, should be false because it's not equal to. So again, here is the answer. Here's the region that makes this inequality true. Okay, next example. Looks like this. Y is less than 3. Well, good news. The first step's done. I've already got y by itself. So now I just draw my axes. And there they are. So y is less than 3. So again, this, because it's just y, this is going to be a horizontal line. So horizontal. I won't say it 4 times like Khan Academy. Horizontal. Anyways, so this also means y is less than 0x plus 3, right? So therefore, you know that your slope is 0, which is a horizontal line. And I start at my y-intercept, which is 3. So there's my point, and my line goes straight across, like this. Although you may want to yell at me right now, I've made one mistake. What mistake did I make? Think about it here. Y is less than 3, so that means it's going to be a dashed line, right? 'Cause it's not equal to, it's just less than. So I'll have to do something like this. Take my eraser tool and just erase some spots, and you can do this on your own too if you use pencil. You can just draw a line straight across in pencil and then use your eraser and just erase certain spots. So there's my line, and then y is less than, so it's everything underneath. So all this stuff down here gets shaded in. So all of this, and again, I mean, it should be obvious, y is less than 3, so anything down here, right, y is 2, y is 1, y is 0, y is -1, etc. All of these should make this true. So that's what happens when you have just y in an inequality. What about when you have just x? So first, let me get my axes. Poof, there they are. The magic of having the ability to pause the video and keep going. So anyways, x is more than 2. When you have just x, like the line x equals 2 from earlier sections in this chapter, that's, remember, a vertical line because your slope is undefined. So your slope is undefined. I am running out of room. Hopefully your notes don't look as bad as that. So anyways, that's going to be a vertical line at x equals 2. So just like this. And on your worksheet I gave you for homework, there's an example just like this. It's not the exact same, but it's somewhat similar. It's a less than instead of a more than. But anyways, so my line will be solid because it's also equal to, so this is fine, and x is more than 2. So the question I always get with these is like, well, Mr. Randa, I want to shade above because it's more than, but it's a vertical line, so which way is above? Well, here's the thing. It's x is more than 2, right? Right there, x is 3. Right here, x is 6. Back here, x is -3. Well, which side's more than 2? This side is more than 2, right? X is more than 2. That's what it says. X is more than or equal to 2. So this side gets shaded. If this was a less than sign right here, you go to the left. So that's how that one works. So we're speeding through this right now. I have one more example to show. And this one you'll actually want to pay attention to because this is actually a problem from the homework I assigned. That's right, I'm going to do the last problem in your bookwork homework from 2.7 for you. So here is the problem. It looks just like this. So 1 minus y is less than the absolute value of 2x minus 1. So now we've got absolute value. Well, what happens? Well, again, just like what happens on my second page where I gave you the goals of what to do, the first step, solve for y, and you still worry about step 2 and 3 also. So solve for y is a solid or a dashed line, and then you shade above or below depending on which way the arrow points in your inequality. So back to this problem here. I want to solve for y. So from both sides subtract 1. But I can't subtract 1 into the absolute value. So this still stays 2x minus 1 absolute value and then minus 1 at the end. So yes, you have 2 minus 1s. You don't have a minus 2 inside the absolute value bars. It's just a minus 1 right there. So now I want to get rid of that negative. So everything divides by -1. That's everything, right? So each piece divides by -1. So on the left side I have just y. On the right side I divide by negative. Sign flips over. And then it's a negative absolute value 2x minus 1. The absolute value, what's inside, right? Think Great Wall of China, stays the same. But the outside now I have that negative sign. And then it was minus 1 divided by -1 plus 1. So basically now I have to graph this inequality right here. So let me get my axes. Here are my axes. The x-axis is here, y-axis is here. So then what I'm going to do right now is fill out this table right here. So to save you time, I'm just going to do it for you. And here it is. Your table looks just like this. So you can check this on your own if you want, but these are all my values. Notice that right here, I changed directions. right? I was going higher, now I'm going lower after 0, when x is 0. The vertex is actually going to be, in this case, the point 1/2, 1. So that point's on my vertex, so 1/2, 1, it's like right there, right about there. So 3, -4, right there. 2, -2, right here. 1, 0, got the vertex matched. 0, 0. So now you start to see the V. -1, -2, and it's somewhat steeper than normal. -2, -4, right there. -3, -6. So here's my V. You can kind of see it. I can kind of tell that that point's going to exist there too, just kind of by following the pattern. So this is a greater than sign, so it's not equal to. So it's just like with lines, it's going to be a dashed absolute value upside down V looking shape like this, and then it's more than. So it's like before, I shade above. What that means is I go, well, here's my V, or upside down V, I go above. So everything up here gets shaded. So I can kind of just show you here, all this stuff gets shaded above. So in this case, above is actually outside, just coincidence. If this was a less than, then I go below, which would be underneath this upside down V. So that's what the graph of number 18 in your homework should look like. Again, if you're not sure how to find the vertex, watch video 17.5. I'll show you how to find the vertex on your calculator, and also how to find it by hand. There's a couple cool ways to do that. I don't care which way you pick, as long as you use one of the options. Your TI calculator can be one of your best friends in this class. It can do a lot of the hard thinking for you. Anyways, that's what I have for this video. So now hopefully you've seen absolute value inequalities and linear inequalities. So now you can graph those. This was probably review for some of you from Algebra 1, but again, it never hurts to see again. Sometimes you get a little rusty. So again, guys, thanks for watching this video. I really appreciate it. I think that this class has gotten a lot better in the last couple weeks. Overall, I'm seeing the video count views are going up. I really appreciate that. Trust. My mic just cut out, but trust me on this, guys, that I think this type of class will be a benefit for all of you. So, anyways, that's all I got. Thanks again, and see you next time.